All right, and we should be live. Welcome, everyone, to another edition of Community Office Hours. Today, we are talking about the Terraform ecosystem, and specifically within the Terraform ecosystem, we are talking to Philip Laine of the FluxCD provider. So we have a lot of fun questions queued up today. If you do have any questions, please feel free to throw those into the chat, and we'll get those questions asked and talk about. So before I jump off and do some introductions, I do have some housekeeping notes here today. I'd like to share with you the community guidelines. Now, what are these? Really, this simplifies down to please be excellent to one another. The internet is a giant sprawling place. Lots of interactions happen every single day, and we really like to ensure that those interactions are the best between people. So please be considerate, respectful, professional, kind, inclusive, friendly. Again, just be excellent to one another. If you would like to check out those guidelines in a bit more detail, I'm going to go ahead and put that into the chat here. So please feel free to take a look at that. We already have our first listener, Kareem Satirli, saying, Philip, hi. So thank you very much, Kareem. Awesome. So without further ado, Philip, I'd like to turn it over to you for an introduction. Could you tell us a little bit more about yourself and where you've been, what you've done?
Yeah, my name is Philip Laine. My day job, I work as a kind of a DevOps engineer, if you want to call it that, at a company called Senate. Day to day, what we do is we run Kubernetes clusters as a service for customers. So it's like kind of a namespace as a service solution. And kind of on the side, or as a complement to that, I'm also part of the maintainer team of a project called FluxCD or Flux. And it kind of, these two things go very much hand in hand with each other. So a lot of things that I do on my free time, or kind of has turned into something that now that I work with a lot. So we're internally at Senate, we also we're heavy Flux users.
Keeping a lot of things in flux, it sounds like. So that's good to hear. One question I had was that people that are kind of newer to Flux, FluxCD and the Terraform provider, can you tell us a little bit about what Flux is and kind of how that fits together with the Terraform provider, just kind of like at a higher level?
Yeah. So beginning with Flux, Flux is a solution that enables you to achieve continuous delivery in a strategy which is called GitOps. What GitOps does is the idea of GitOps is basically that you have a repository that has a source of truth. This repository is usually a Git repository, and you have some sort of daemon running inside of your cluster that is continuously synchronizing with this Git repository and basically taking the source of truth from Git and making it happen inside of your Kubernetes cluster. So it's turning the whole cake kind of upside down, where instead of pushing things into your deployment environment, you're now instead pulling things into your deployment environment. And it's the ideas that are kind of described aren't specific to Kubernetes, but it's just that Flux is a project that implements this GitOps idea for Kubernetes. What the provider does and how it relates to the Flux project is that initially there was a Flux v1, which was compared to how Flux v2 looks today, it was a simple solution. It was a single application that was running. It did not make use of things like custom resource definitions. And the configuration was kind of limited. That enabled the maintainers to offer a Helm chart to simplify the installation of Flux v1. And as work began on Flux v2, which started maybe soon 2 years ago, it became apparent that the whole project was moving over to multiple separate controllers inside of Kubernetes. but also moving over to using custom resource definitions to configure different settings. So originally, for example, you would run Flux v1 as a single instance looking at one Git repository. And if you wanted to synchronize from multiple Git repositories, you'd have to run multiple Flux instances. And this switched over to a single controller with multiple configurations coming then from custom resource definitions. An issue with Terraform today, and the whole provider came from a very selfish source, I guess, because we are at Senate heavy Terraform users. We're using Kubernetes, and we wanted to use Flux. Using Flux v1, it was kind of easy because there was a Helm chart. There's a Helm release resource. Installing Flux was pretty simple with Terraform. But everything became a lot more complex with Flux v2, partially because there were, instead of one controller, there were now 4 plus 2 if you want to do image automation. But then there were also the need to install the custom resource definitions and do all that type of management. And currently in Terraform, working with custom resource definitions is not the easiest. And from the Flux project's perspective, we were looking at like, how do we actually deliver this to the end user? Initially, the only way to install Flux v2 was with the CLI. So it would manage everything for you. And the CLI would be updated with a specific version, and that would include updates to the different controllers. And so that basically allowed you to, if you wanted to use Terraform to install Flux, you'd have to shell out and use a null resource. So the provider came as an alternative to that installation method, basically.
Interesting. And I think that it's been an interesting journey to kind of watch how it has evolved on Kubernetes when it comes to, do you install the Helm chart or the operator? I think that, like you said, CRDs coming about were something that were really helpful in kind of packaging these things up. Though it has been funny talking with some people that have maintained projects where they, you kind of like, you start with the Helm chart, you start with the Go templates and kind of the structuring of that. Then you move to the operator, then you find out a way to package up the operator into a Helm chart. You kind of go all the way one direction, then double back, which has been kind of funny to see with some patterns on that front. But really thankful for CRDs and making that a little bit easier to package up. And really happy to see that now we can start to install less things to be able to handle those workloads and really just enable GitOps in a lot of places. When it comes to maintaining the provider in the project, how has that experience been? Has it been interesting or enlightening? Have there been any things that you've learned as far as working on the project and working kind of in public, if you will?
So the provider today is pretty, I would say, self-reliant, mostly because I have not had too much time since summer to do larger changes. But also because the initial work that was done, I think it's a year ago now, was focused on figuring out how the alternative to installing Flux with the CLI would look like. So things like, okay, you could install it once, but how would versioning be managed? And according to me, the provider is not the thing that does all the heavy lifting. So the provider, what it does in basic sense is it exposes 2 data sources. One data source that gives you the manifests to install the controllers, and one data source that gives you the Kubernetes manifests to set up the initial bootstrap synchronization. The provider does not take responsibility for actually applying these things to the cluster. Instead, what we've done is we've written documentation examples to show how the Flux provider in combination with the kubectl provider can be used together to install these things. there has been some criticism for asking like why the Flux provider is not taking all the responsibility. It would just be a lot easier if I just configure the provider, give it some connection string or client certificates, and just expect the provider to do the version upgrading and everything. But my feeling was basically, one, it would take time, both like building it initially, but also then maintaining it and managing it for the future as new Kubernetes API versions come out. And two is it would go against a lot of the ideas of Terraform, which is kind of building on top of the power of multiple providers. If there is already somebody who's built a kubectl provider that can apply raw manifests, why should I re-implement the same idea in a very specific use case? But development has been kind of interesting from the perspective of I've built providers before and they've been internal use, and that's kind of fine. But as fast as you build something that's public, you end up with 100 different other use cases and 100 different other errors, and then you have to build something that will work in the future and not break people's state. And in combination with that, you're kind of, the whole setup is dependent on other providers. So the issue could be in some other provider that is broken. So it's like kind of, you're walking a very fine line between solving other providers' issues and solving your own, really.
That's a really good point in terms of focusing on kind of like what is the problem that you're trying to solve, and then not ingesting some other provider's responsibilities or tasks or kind of duplicating that functionality. I think that that's really important. And even when it comes to Terraform, I feel like people really enjoy that Terraform apply that spins up your infrastructure and handles like stringing everything together. And I also see the line blurred there a little bit where it comes to configuration management, and where Terraform might not, it's easy, it's nice, but it might not be the best tool for handling that task or that workflow. So it's interesting to kind of hear. I keep hearing that in a couple of different circles. So really, really inspiring to kind of hear that again, and understand that abstractions are important. It's helpful to have the right one.
Yeah, and looking at, for example, the Flux CLI, it is basically doing all these things that people would expect the Terraform provider to do. So it will check your cluster for compatibility. It will install all the CRDs, the controllers, and bootstrap your cluster. But it also then currently, I think it supports GitHub. I don't know if it supports any other Git providers. It will actually go and create the repository for you and commit the files for you. But the issue here is then somebody comes along and says, okay, I want to install the Flux controllers with Azure DevOps or GitLab or Bitbucket. Then you end up in this like never-ending marathon of supporting every single use case, basically. And compared to that, the Terraform provider most of my time is spent building examples, explaining to people, okay, I want to do it with this Git provider or this cluster provider, and how does that work? And then figuring out, okay, so what providers are out there? I don't have to build the integration with GitHub, for example, because there is a GitHub Terraform provider.
Absolutely, and I'm sure that also is that has to be interesting too in coding against all of these implementations, especially when it's like, could I, does anybody have a Bitbucket account I could borrow or something like that, But that must be interesting. It's when it comes to the future of the project, kind of going along with what you said with implementing all these different things, what do you see as some of the next things in the future of the project, and some of the things that you either want to work on or see, or kind of what you have in your mind right now?
My hope is that eventually the project will be archived, or not Flux, but the Terraform provider component. Because I see a bigger need than just Flux. So there are basically two ideas of how you're configuring your Kubernetes clusters and if you're using Terraform. So one of the ideas, well, I'm creating my cluster with Terraform, either by setting up VMs or you're using some sort of managed Kubernetes control plane. And I want to deploy applications with Flux. So all I'm going to do is I'm going to bootstrap it with Flux. And then that's where Terraform's responsibility goes away and Flux's responsibility kind of enters. Then obviously your application might need to have some dependencies towards other cloud resources. So you might be using Terraform there, but that's kind of a separate component. You want to keep those separations because it might be two different teams doing these kinds of things. And the other idea is, well, I'm creating my infrastructure, but I'm doing all configuration separate. I see it as like there are certain components within your cluster that could be considered like core infrastructure components that you have no interest in running this cluster without these very critical components. That might be if you're running AKS in Azure, that might be things like AAD pod identity to do like Azure identity role assumptions in your pods, or it might be OPA Gatekeeper to do like constraint and rule management within your cluster. Like you don't want to install Flux until you have Gatekeeper running in your cluster. That might be a very typical use case because it's like, yeah, this has to always run. So you set up a depends on between these two components then. But you end up in a situation where Gatekeeper itself also uses CRDs. So how do you install Gatekeeper? All these projects, or a lot of these projects, all are built around the same kind of tooling that comes out of controller runtime. Or I actually forget which SIGs it is. Never mind. There's a SIGs that basically builds this tool called KubeBuilder. KubeBuilder allows you to set up the whole or template a some sort of starting point for a repository where you create your controllers. I honestly think it would be better to figure out how to develop a provider that would allow you to install these controllers in a unified manner. There are a couple of projects out there, but there's nothing that really works well with Terraform. Helm isn't an option because Helm doesn't manage your CRDs. So it's mostly a question of how do you deliver controllers that are versioned with CRDs together with the controller versions itself in a reasonable manner that can be updated and upgraded. So my idea is basically not that the Flux Terraform provider is the future. It's more of a generic solution that would work for multiple controllers, because I think there's a bigger need than just Flux.
That's an incredible answer too, and I think that's not normally one that you get too. Is like, you know, like I hope that this project is a stepping stone to get to this place. So incredible perspective on that front. I agree. I really would like to see that when it comes to CRDs and making that easier, because like you said, you get into this problem of circular dependencies and having to worry about, you know, how you get back to that synchronous kind of workflow where it's just like, oh shoot, I need to have these things to have that, and you kind of have this whole decision tree process. So that's not the most fun unless you you enjoy kind of going through that decision tree. But cool. When it comes to kind of building that future, are there any ways that people can help get involved and kind of helping the Flux provider get along and get closer to that goal? Do you have any tips for that?
PRs are always appreciated. I think the best PR right now is documentation. It's okay. I'm running GKE with Bitbucket. This is how I set it up. So if you have solved a specific use case, writing it down and documenting it and creating a PR with that documentation is usually, or right now, the best thing people could do, because it will solve a lot of issues that exist right now, or solve a lot of questions where people can just go, okay, I read the documentation, I found something. I might not be using GKE, but I'm using Bitbucket, so I can like take parts of that solution and kind of apply it to my use case. Other than that, there are some small maintenance things that has to be done with the provider, but it's I think documentation is kind of the biggest thing right now, or just more examples rather than just writing documentation.
I agree that that's one of the most helpful things that you can add to a project. I feel like when taking a look at the Kubernetes project as a whole, it's interesting to see some things that it just really helps to have that extra context and those extra examples. I know that one of the items I've been more curious about lately is taking a look at jobs and cron jobs, for instance, when it comes to Kubernetes. And when you really drill down into cron jobs, there's definitely some gaps there and some things that might help when it comes to analyzing what's going on from the documentation on the website. But that one of my favorite kube control, commands has to be explained and kind of looking through things that might not reflect in the documentation on the website. So documentation, one of the best features. Absolutely have to agree with that.
But you see that a lot with all other providers that have really good documentation. The documentation page for a specific resource, when the initial example there is not only this resource without the context of other dependencies, it actually gives you, for example, if you're creating a service principal in Azure, it shows you how it links to the Azure application registration or whatever. It's like it gives you the full context. That's kind of when the documentation actually is helpful, rather than just here is something that kind of hopes that you understand everything else you have to do around this.
Exactly. It's I love that so much more than sure, it's possible, and then kind of no way to go and achieve that. So absolutely agree. Cool. So I was taking a look at the project yesterday, and I've used it in the past, and you mentioned before it was really nice to have the provider go about and actually spin up the GitHub repository and kind of put everything together. I really liked that. When it comes to, I saw that about 2 weeks ago, the 0.30 release came out. Can you talk to us a little bit about that and some of the features that were added in that release and some of the workflows that helps enable?
It hasn't, the last release was not too big. I think it was a major update of the controller versions. As there were some breaking changes, that's why a major release had to be, or a minor release had to be done, because in a way to show that, okay, so there's actually something more important than just small patches that have been fixed. I've been looking a bit about looking at doing a lot of variable or input validation, which is kind of a typical gotcha that people get stuck on, where the actual installation code will error out, but it might be easier to catch these type of things in the plan time compared to kind of allowing the user to figure those types of errors out in the future. But other than major version updates, it's kind of hasn't changed that much since end of summer. One of the things that kind of is a bit difficult is the versioning between, or the link between the provider version and the controller versions, and how those two relate to each other. Because what happens is when a new provider version comes out, it bumps the default version of Flux to something, and that kind of trips people off sometimes, because you can technically set the version to something else, or you could kind of update the provider and allow the provider to take you forward. So that's kind of something that people get caught up on sometimes.
Are there any interesting ways that you've seen that the project get used that you didn't expect, or any integrations that you've added that that also you didn't really foresee?
Initially, the development of the provider was done together with GitHub, because it was kind of, the whole thing was built around, okay, so this is the well working use case that the Flux CLI installation method can support. So let's solve this with GitHub. And that worked well until you started looking around and going, oh, how do we support GitLab? How do we support Azure DevOps? How do we support Bitbucket? And one thing I realized pretty quickly was that most of these providers allow you to create repositories with the provider, but not repository files. So that's kind of a very big gotcha where people go, yeah, what's up here? I can't use it with Bitbucket. And it's like, I know there's a PR open for GitLab to add this. I have a long running PR for Azure DevOps, which I probably should get around to fixing the comments there. So I've been running my own fork for that for a while. I'm not sure about Bitbucket, but that's kind of one thing that people avoid implementing in the providers, it seems like. My hope was we had a good look at building a generic Git provider, but that would also introduce a lot of complexity with how Git libraries and Go work together. And I kind of won't bore you with the details, but there are a lot of weird things when you end up trying to figure out how to get Go with Git working, and then realizing that different Git providers implement Git in different ways, which can also mess things up. So even if you build it in a generic fashion, it's still going to have some weird edge case for some other Git solution. But that's kind of, I think that's one of the things that I realized was like a big missing provider in the landscape of Terraform providers today.
Again, making for kind of a fun use case as far as the circular dependencies and kind of how to string these things together. Another interesting take on abstractions.
Yeah.
Awesome.
Another thing is just looking at, like, for example, we're using a third-party kubectl provider as an example. I've seen some other people do other things, like using null resources or using other providers to solve this. I haven't really seen anything that's like kind of way out there. It's usually people with very specific use cases. Like I need this specific security setting on one of the controllers, for example. How do I patch that? And we've had to build some examples around those types of use cases.
Interesting. There was another question I had for you, but really quick, want to say thank you all for joining today. I do have a lot of questions, but if there's anything that comes to mind for you and you'd like to ask Philip or myself, please feel free to throw it into the chat and we'll get those questions asked and answered. So please feel free to share those. Philip, when it came to one thing that was kind of top of mind that keeps coming back to me was when you talked about spinning up a Kubernetes cluster and ensuring certain things are installed, kind of like as your starter pack. I can't agree more. Kubernetes allows you to put together an application and to kind of host it, orchestrate it such that you can actually go about using it, connecting with it. But you can do that with a deployment and a service. But after everything is said and done, you want to enable your company's security policies and all these other things. Are there any specific starter pack items you like to have within your Kubernetes cluster? I know that obviously, FluxCD and that provider would be wonderful to have. Are there any others that are kind of like your go-tos when you spin up a cluster?
Oh, I can. We have a standardized module that basically configures everything for us. So because we've realized that over the last maybe year and a half, building custom solutions for each customer really wasn't a maintainable solution. So what we've done is we've set up a module that contains all the different things that we're interested in, both for EKS clusters that we're running and for AKS clusters. And obviously, one of those is Flux. But on top of that, we install most of our what we call like core infrastructure. So for AWS, because we're running Calico, that's kind of the biggest challenge, is figuring out how to install things or install Calico on an EKS cluster with Terraform. That's like, those types of things are like a must, or you have to install Calico before anything else is installed, which kind of becomes a big challenge. Other than Gatekeeper, I'm like, really can't think of names now. We have a couple. I think we're running, every cluster has to run Falco, and we're heavy users also of the CSI Secrets project, both in AWS and Azure. So that's kind of one of those things that kind of our Flux installation is dependent on CSI Secrets provider being present inside of the cluster. So, you end up in this, as you're saying, this kind of chain, which Terraform, due to how Terraform core works and its dependency management tree, is kind of, that becomes very nice. Flux actually has the same type of logic in it, but because you can't install Flux with Flux yet, or you can technically if you're using Cappy, but that's like a whole different story. But you end up in these like kind of things where it's like, okay, so to install Flux, we want the CSI secret store provider, and before that, we want Gatekeeper running, because Gatekeeper will mutate that and ensure that it has sort of certain capabilities that it drops and things like that. So it's, I think it's a long list of things that we install, but I don't think there are that many that are like must-have things. I think one of the really good projects that I don't know how many people are using is a project called Reloader. The only thing it does is it basically allows you to configure your deployment so that when a config map is updated, it will update your deployment or restart your pods, so it like rereads the config map. That's one of those things that really helps.
Interesting. I haven't checked that one out. I know that what was it? I did like that's been a big gotcha for, in when working with Kubernetes, the secrets versus config maps and reloading and making sure those pods have what they need. But interesting. I kind of like that focus on making sure that you have what you need when you get your Kubernetes cluster started up. And I like that you've kind of found the right balance to strike there, because it can be exhausting. You could have 30 plus things ready and running and available for you, but then you kind of reach diminishing returns in terms of how helpful that is versus how much it takes to actually configure and manage those kinds of things. So good to know on that front.
Yeah, you want to kind of leave it to like separate deployment cycles, where it's like you obviously don't want to deploy all your applications in the same state as you're setting up the cluster. That would kind of be a mess of access management and deployment or application lifecycling. So it's like you want these kind of clear boundaries between, okay, so we're doing this here, we're doing that there. What I think is future for Terraform when it comes to Kubernetes is running Terraform inside of your cluster, which is kind of a scary thing, but I've had some ideas of how that would work. But it would be pretty cool if you could, for example, deploy with Flux your application, and your application may depend on a Redis instance or as a service solution, or a Postgres database that you run or you get from outside or from AWS or Azure. And just the possibility of saying, okay, so this is my manifest for my application. Here is the Terraform that sets up the database, and it outputs the connection string or the URL to the database, because it might be a dynamically generated thing. And that output will then be placed into a config map automatically, so your deployment can't start until the config map is present, which creates a kind of a dependency between those two. So it's like those, I think that's kind of where the next steps of like Flux and Terraform. So it's like Terraform setting up Flux, then Flux deploying, so it will help you run Terraform.
I like that flow. It's I've there's still a couple projects I do want to see, like especially I think I've talked with a few people about Nomad spinning up Kubernetes clusters and managing those, vice versa, Kubernetes spinning up Nomad and kind of managing that. So that's I do like those possibilities, and kind of even if they're just thought experiments are quite fun to kind of go through and to take a look at. Awesome. I think when it comes to, I think you hit upon it a little bit, but when it comes to, this is a two-parter, but when it comes to Terraform, when it comes to Kubernetes, are there any things that you'd like to see developed in the future, or are there any, are there any shortcomings with either that you kind of want to see get fleshed out a bit more, or are there some kind of more ambitious things you want to see both of those projects achieve to kind of help the Flux provider a bit?
So for the missing things in Kubernetes, I think a major part is how jobs are managed and run. And this kind of applies to running Terraform inside of the cluster or doing other types of things. Being able to trigger jobs, schedule jobs natively isn't really that well supported outside of cron jobs. I think that adding support for things like webhooks natively, where you could call on some sort of service and have a job trigger, would be very nice. But from Terraform's perspective, I've been following the whole alpha provider, Kubernetes provider work that's being done. That is code-wise very interesting, as it has to diverge heavily from the typical provider methodology, as it takes dynamic data. And anybody who's written little Go kind of realizes that dynamic user inputs and Go isn't really the most fun thing to work with, as there are no generics and you have to use different libraries to be able to deal with that type of stuff. But it's a beta feature right now, right, in the Kubernetes provider to apply CRDs. The biggest shortcoming there is that it requires you to create the cluster and the actual thing that you're applying in separate states. I've had some discussions about building an automatic pipeline that would, when Flux is released, take the YAML, convert it to HCL, and like publish that as a module. The issues, there are two issues really with that solution right now. Partly it is that this module is going to have a lot of issues regarding different configuration values. You have to basically hit every person's use case. The other one is that the way Flux Bootstrap works is that you take a collection of manifests and you apply it to the cluster, but you also have to take the same manifests and commit them to Git. And that's kind of the challenge of even using even if it was possible to use the beta feature in the same state, you'd still have these issues. But I think that's a possible future. It might be in the future where there's a tool. If you're building a queue builder project, you could run this tool and it would generate you a module for you. That might be a very nice solution. But I really think that solving the whole, and I understand the technical limitations because it's using server-side apply, so it can't really run the plan without figuring out or having the API server there in the first place. So there are limitations there. But if that could be solved, I think there's a interesting future where these types of tools could be developed instead of having a provider. You could have a module and then you can easily version the module, and that could be like your release artifact, if you want to call it that.
Yeah, I think that's something that I've seen too, is kind of come out when it comes to creating a pattern to work with Kubernetes and Terraform together. Was I understand that a little bit more when it comes to understand the technical limitations, like you said, and have seen that trip up a few people, myself included. I look in the mirror, I see somebody that got tripped up. And when it comes to having to have that cluster to actually instantiate those things. I do like the pattern when it comes to configuring your Kubernetes cluster, because I have seen people get messed up when it comes to upgrading a cluster, having a managed DKS cluster, and then kind of like your authentication details in your Terraform state getting out of band or aging out. And then you're not able to connect to that cluster. You spin up the new cluster and it's using the old credentials to try to connect. So separating that instantiation of the cluster and then configuration after that works really well. That's a clean abstraction to work with that. But that it just comes with the complexity of managing that pattern, or being like, oh yeah, I don't have this Kubernetes cluster yet. I can't do this thing yet. Kind of similar to the other conversation that we had a bit earlier. That can be enlightening, frustrating in some points, but enlightening in others.
Yeah, I think the way that we do it today is that we have separate modules. So one module that sets up the cluster, and then another module that does the configuration, but they're still in the same state. So we're kind of in the situation where we can't use this beta feature. Before that, a lot of the typical way we would do it is we'd create everything with Terraform, then we'd run Ansible to do the actual installation of things. We moved away from that pretty quickly because we realized that it was pretty easy to end up with the Ansible and the Terraform drifting out of sync with each other, and you'd end up basically applying the Terraform, not applying the Ansible, or the Ansible would fail, and the Terraform would succeed, and these types of things. So I am a heavy proponent of keeping these two like heavily or very closely linked to each other, just because it forces you to think of, okay, so if this is too annoying, shouldn't it be somewhere else? Like, shouldn't this be deployed with Flux instead? If it's something that you're continuously updating, because it's like usually with these types of infrastructure components, you might update them once a week at most. It's like a month. You're probably doing these two things like as a, okay, so we're actually gonna update like the CSI secret store provider, and I'm not gonna throw the latest version out there because I have hundreds of applications that all depend on this thing working. But I think that's kind of the two ways that we can go right now, is either solving the whole how do we deal with CRDs and Terraform, and it's kind of weird because it's like Terraform with its static typing of data, and CRDs where anything can contain anything, because it's the server kind of tells you, okay, so here's a API spec for it. I think it's going to be a big challenge. So it's like either the solution will be figure something out there, or building a very generic provider that solves the installation for all KubeBuilder projects. Sadly, I was hoping for Helm to be able to solve the whole managing CRDs, but that's kind of probably never going to happen the way it looks today. So I think that I don't really know if there's any other project out there that's kind of struggling the same way that Flux is. Flux is in a very weird spot where it has to do a lot of things in the installation process. It's not just only applying a set of manifests to the cluster. Yeah, so it's our bootstrap process is even like more complicated because we're running Flux in a multi-tenant solution. So on top of applying things or bootstrapping Flux and committing things to a Git repository, we're also then committing more files to the Git repository to tell Flux to go look at other repositories for configuration that it's going to pull into other namespaces. So we're doing all that with Terraform. So this very complex configuration that's kind of even complex with the Flux CLI is just simplified into a single module that goes, okay, give us all the tenants, their repo URLs, and it just goes and does it for you.
I do like that flow, and it's I feel like it feels great when you're able to actually get that implemented and done and kind of see it working on that front. But that's not simply done. I think it does take a lot of time to kind of tweak that, turn the knobs to get things just the way that you need them to be and to exist. But cool, incredible insights on that front. Just as a reminder to all of you out there viewing with us today, if you're viewing live, please feel free to throw in any final chat questions that you have, and we'll be sure to get to that. I did have one remaining question before starting to wrap things up and asking any other questions that come up. But what ways have you seen GitOps help teams and kind of like either restructure their thinking or enable bigger possibilities for those teams, or helping them to move a little bit more agilely? What have you seen out there when working with a FluxCD provider?
So a major benefit of GitOps, looking from the perspective of application developers, maybe not like my day-to-day job, is it forces teams to really separate what you could consider as CI and CD. Before this, a lot of development cycles might look like, okay, so I'm updating the manifests for a application, and I would trigger a build for it, which would result in building the Docker image, linting it, and scanning it, and then applying your changes. And it's like, for me, that's not a logical thing to do, really. It's like, why are you chaining together all these things? If you're changing the configuration of something, you don't have to rebuild the image. That's like one very big component of like, okay, so it certainly is possible to do this with a normal deployment flow, but it kind of, because of the way it works, it forces you to get into that kind of way of working. Other than that, what I've realized that it kind of puts more focus on the manifests itself and your configuration. Usually those things can be hidden, and your continuous delivery pipeline becomes kind of magic. It's, I commit something and it deploys, and you're kind of figuring out why things aren't working, and running through pipelines and looking at those types of things. And obviously GitOps, due to kind of its new-ish nature, introduces problems in educating people and in the new way of thinking, and kind of it introduces partially new problems that you didn't have before, but also looking at current solutions that are done with a push-based deployment method and figuring out, okay, so how can we fill these feature sets? From an operations perspective, it's the idea of having a cluster with 20 different teams all deploying into a single cluster, and then just being able to, with Terraform, go, okay, yeah, I'm going to set up a green cluster. It's going to point to the exact same repositories, allow it to sync, deploy, and then just repoint the DNS and remove your old cluster from Terraform, and nobody has to be the wiser. And the way that we work is that we have our custom authentication proxy that we can control which cluster it authenticates to, and the tokens will still match, which means that we can replace a full cluster during the night, and no developer will actually be the wiser. I just have to plug in my charger, sorry.
Yeah, no worries.
Just realized that.
Yeah, what is it? They say that magic doesn't exist, but I've definitely seen it, and that is as soon as your pipeline is working correctly, I think that's when when magic is truly in existence. But awesome.
Oh, there we go. Yeah.
Awesome. Cool. It's I was just saying they tell us that magic doesn't exist, but I think it does, and it's when you can see a working pipeline. That is truly magic.
yeah, debugging pipelines isn't really the most fun thing to do. You're just like doing 100 commits just to figure out why this one thing won't work, and you're kind of in the blind.
Yeah, just that's always a fun thing to see, is that just testing, and then it's like 10 or 20 commits. Awesome. Well, taking a look at the chat, I don't see any new questions. Again, if you have any final things you'd like to put in there, please feel free to throw those in. But with that, I think it's time to start wrapping up. Philip, I'd really like to thank you for stopping out here today and having a chat with us. It's been incredibly enlightening to hear all of these things and to kind of understand the FluxCD provider in a deeper light and get that deeper meaning from everything that we've talked about today. With that, are there any closing thoughts or mantras or sayings or anything like that you have for the group? I know it's a lot of pressure. I'm putting you on the spot.
Yeah, no, but if anybody out there is interested in helping out, looking at kind of seeing that, okay, so my project has kind of exact same problems that the FluxCD provider solves, reach out. It would be very interesting to look at how we could build a generic solution that would solve this problem for multiple people or multiple projects.
Awesome. Well, with that, I'd like to thank you all. Thank you again, Philip, for joining us today. Please feel free to add us if you have any questions regarding the FluxCD provider or Terraform or anything else in the HashiCorp stack. And we will see you next time. Thank you for joining us for Community Office Hours. My name is Taylor Dolezal. Thank you to guest Philip Laine for joining, and we will see you soon. Thanks, everybody. Have a good one.
Thank you.